to the beginning. You can't undo this. It bypasses all of the overhead that you get to have to deal with when you're inserting and updating and deleting data. So if you are doing bulk transactions, you're going to use it. But for the sake of this class, you're not going to. Yeah, get those out of order. So a transaction, you can do multiple inserts and updates and deletes. When you're doing in PHP-MyAdmin, it commits them every time you do them, which is it saves the changes. If you're using something like MySQL Workbench or command prompt that you can just issue a bunch of updates and deletes, it won't actually save those until you issue a commit. And a commit is just save the data I've changed. When you do a commit, it commits all of those changes that you've made up to that point. It doesn't just insert some and then fail. All of those statements are validated before it is committed. And if you don't want to make those changes, you can undo everything you've made up to your commit by issuing a rollback. It's essentially an undo. Like I said before, if you were truncating out data, truncates you can't undo because they are not DML statements. There is no logging and stuff that goes along with that. All right, so that's the boring, broad overhead of databases. Even more boring is that you've only been able to select from one table so far. So what you want to be able to do with your database is kind of start doing some more complex analysis. So we're going to start going into more querying capabilities. Star. If you're typing a query, star means all columns. If you have multiple tables in your database or in your query, star means all columns from all tables. Or if you have it aliased, all columns from this table. Distinct. Distinct will, if you remember from that query that I ran that I had bread twice, milk twice, water twice, distinct will give you only a unique list of the values that are returned. So if you said give me all the recipes or give me all the authors and a user had multiple recipes in there, he would be listed each time he'd be listed for each recipe that he has. If you put distinct on there, he only shows up once. Case statements. These are conditional statements. So if you are doing a select statement and you have a quantity and you want to measure that against something, and if it's over 100, you want it to alert somebody. You do a case. When something's over 100, then this is too much. When the quantity is under 11, it's too little. Or else it's just right. So this lets you put conditional statements inside your SQL. The streaming software is slowing down my computer a bit.
Now, what's the next part? Like it's how it will appear on the screen.
Say that again?
Will it appear on the command line?
No, this you could just take and run as regular SQL. This isn't a command. This is SQL. So if we take that and we go over to SQL, we're down there. I'll circle back to this one. It's a syntactical difference between how Oracle does case statements and MySQL does case statements. I do a lot of Oracle stuff, so a lot of this stuff was written in there first. But that shows up in it should just show up in a regular statement. So if you had quantity in here, unknown column quantity. I'm not sure. right, I'll circle back and answer this one for you later. So what it should do is instead of returning the quantity in the SQL or in the results, it should return a text field that says one of those things. So it's no longer giving you quantity anymore. It's giving you some kind of analysis that you've done on quantity.
Okay.
I know in corporate stuff
So
they say
that,
if
that text field will it's going to be instead of the query, right?
oh, it'll be the query. It will be the query. So that case statement is part of the SQL. So you would put that in the query, and then instead of getting back quantity, you'd now get back a field that did what you wanted to do to replace it with. So what this is saying is when the quantity column is greater than 100, then take that quantity value and combine it with a string that says this is too much. So if you have 105, this isn't going to say 105 anymore. It's going to say 105 is too much. If you have 1 in there, which is less than 11, it's going to say 1 concatenated with is too little.
So that is a concatenation sign?
Yes. I have to double check with MySQL, but this is the Oracle and a couple other databases concatenation sign. There is a function in MySQL called concatenation, which looks something like concat string 1, string 2. And that might work. Maybe that's why it's yelling at me, but I'll worry about it later. I'll follow up, yeah. Arithmetic. You can add numeric columns, you can subtract, divide, multiply. You can do modulus, which is the remainder. And that's all done in the SQL as well. SQL. Select quantity times 10 from ingredients. Now there's all my quantities multiplied out by 10. The only restriction here is that your data needs to be numeric for that stuff to work. There are functions that are built into the database. If you have some decimal values and you don't care about that when you're doing reports, there's a function called round. And to apply that, you just say select round, the column that you want to round, from the table. There's a lot of functions. Depending on the database, these are implemented slightly differently. These I pulled off of the MySQL documentation. You have numeric stuff, you have sine, cosine, tangents, pies, other trigonomic functions. You have round, ceiling, floor, and truncate, which are all rounding stuff. Logarithms, powers, exponents, random number generators, and two numbers. So if you have a string field that has a column or a value of 10, but it's a string and you want to do math on that, you can convert that string to a number and then use it for math. There is a bunch of date and time functions like current time, current date, current timestamp. These will give you the time in 24-hour format. This will give you the year, month, day. This will give you year, month, day, and the time. If you pass in a value, there's a function called seconds, minutes, hours, week, or day, in which it will take a value out of that date and tell you this is the day that this date is. So if you feed in Christmas, it's going to give you 24th, 25th, whatever Christmas falls on. If you pass in New Year's or New Year's Day and you ask for the week, it's going to give you 1 because New Year's falls on the first week of the month or of the year. Also, date format is like 2 numbers. So if you have a string that you want to treat as a date, like if you have year, month, day, coming in from some external source, you date format it to convert it to a date. There's some string functions. This is padding and removing white characters on trims or on strings. If you get a lot of data from external sources, a lot of the times it will have a bunch of junk in it. A lot of padding on columns and values. These will help you get rid of that stuff. Left, mid, right, substring all do about the same thing. Will let you bisect a string value. So if you have a description that's 50 characters long, but you only care about the first 10, you can say, give me the left 10 characters, give me the right 10 characters, give me the middle 15 for whatever you need it for. Length will give you the length of the string. InString is a search function, so if you can say, I want to know all strings that have pork in it, I want all strings that have Bob in it, this will tell you if that has Bob in it. You can convert cases on everything, or upper or lower. I forget if there's a camel case or not for MySQL. And there's also regular expression searches. Won't get too far into that. Essentially, you can define a pattern for your searches. So if you wanted to look for a phone number, you can say, give me everything that looks like number, dash, number, without actually having to give the numbers. You give it a pattern to look for, and it will look for that. Some other important ones you're going to want to deal with. Null if. So if you have a column in your select statement, and it is a null value, and you want to be able to use it for something else, even though it's null, null if will substitute the value. So if you have null if column, and you want to treat nulls as 0, null if will replace that field with 0 when you are selecting it and using it. So you can do math on a null column if you null if it to something else. Coalesce takes a list of column names, and it will give you the first non-null value in there. So it's like null if, but it takes any number of arguments, and it will just stop after the first non-null value is found. And last insert ID. This is an important one if you are scripting stuff or doing anything more complex than what you're doing tonight. Last insert ID will give you the primary key of the last row that it inserted. So when we inserted that recipe detail recipe for the first time, we would have called this, and it would have told you, I inserted primary key 1. So when you go and insert all the instructions and all the directions for that recipe, you know to use the 1 that was returned by last insert ID. You have to capture that in a variable. I forget how it's done with MySQL, because once you start inserting more directions, last insert ID becomes the primary key of the next row that you just inserted. All right, so there's some more interesting functions. These are aggregates. These change the way your SQL works a little bit. You need a group by column. Essentially, you are taking all of your data and you're going to sum it up, or you're going to look for max values, or you're going to do averages by some kind of column combination. So if you wanted to see how many ingredients were in a recipe, you would say select recipe, count star from ingredients, group by recipe. What this is saying is, for all the recipes in ingredients, count how many rows there are. And that should be how many, since this is the ingredients table, this is how many ingredients are in that recipe. You can't select anything other than the group by column in your select statement for an aggregate. Or say you can't select anything other than the columns you're using for the group by plus the function. So if I wanted to do the max ingredient ID, I could use that here instead of count star. If I wanted to sum the number of cups of ingredients in my recipe, I could do that. If you are looking for numbers of recipes by author that take less than 120 minutes to do, it would give you that. Sorry. You're gonna, for these aggregates, it's min, max, sum, average, count, count distinct. So if you don't want all of the, like if you have the same ingredient listed twice in your count and you only want it to show up once, you would put distinct ingredient name. There are statistical functions, standard deviations, variances. Depending on the database, there are more or less functions, but they exist. These will not return every row in the table that they're querying. So for recipe details, if you are selecting by author, or you're grouping by author, you're only going to get one row per author, no matter how many details you have in this table. You're only going to get one row per recipe from ingredients, no matter how many ingredients you have in this table. That's the purpose of an aggregate. It gives you summed up data to some level. All right, so we were doing one table before. What if you actually have multiple tables? That's called a join in SQL. It's a regular select statement, and you slap in there an inner join on the next table that you want to include. And then you give the columns that you want to match when you're joining these two tables together. So right now, this thing will give me all the recipes that have peanuts in it. So we're going to the recipe details first to get the recipe name. We're joining it to the ingredients table. And then we're doing a search on a column in the ingredients table that's using some kind of character recognition. All right, you have 4 kinds of joins. You have inner joins, you have a left and right outer join, you have a full outer join, and you have a cross or a Cartesian join. So an inner join is only going to return results in which the column that you're joining on exists in both tables. So if you have a table with a list of colors, favorite colors by person, you have a list of favorite foods by person. If you interjoin these two tables, Carla is the only person that exists in both of these tables. Carla is the only person that will come back in an inner join. And it will say her favorite color is red and her favorite food is pizza. A left outer join means no matter what the matching criteria is for this, always take all the rows in here on the left, and if there's no data to join them on the right, just leave it blank. So if you left outer join colors to food, you get all of the 3 people that are here, Alice, Bob, and Carla. And since Carla is the only person that had a favorite food, she's the only one with a non-null food value. A right outer join is just the opposite. If you said right outer join here, it would have been Carla, Dylan, Eric in the results. And it would be red blank blank and then pizza taco steak. So it's just the opposite. If you change this to right, or you just swap these 2 tables out, it has the same effect. When you do left, this is the one that it uses to get the full list. And when you do a right, this is the one it does for the full list. A full outer join will give you back all columns in both tables. So if you outer join these 2 tables, you'll get everyone from this list, everyone from this list, and if you exist in both, you have access to both of their records. This one should read cross join. A cross join is completely useless, but it exists. A cross join just means combine every column that's in this table with every every row in this table with every row in this table. There is no join condition. It just says cross join this table to this table. So Alice will be joined to Carla, Dylan, Eric. Bob will be joined to Carla, Dylan, Eric. Carla will be joined to Carla, Dylan, Eric. The only time that I've used this is if you take a date. If you have a list of dates in one field and you have a list of hours in another table, you can quickly take those, combine them, and create a full list of all hours, all days in those 2 sets. That's the only time I've ever used this.
Basically distributes one table to the other.
Kinda. Because there's really no rhyme or reason on how it distributes. It just distributes it everywhere, and what do you do with it at that point? So if you have a special use case where you need to combine everyone, then yes, but once you have them all combined, you have to do something with them. Otherwise, it's just garbage. All right, so if you have 3 tables, 4 tables, 5 tables, the syntax is the same. Inner join, new table, left outer join another table, so on and so on. You can You can put in, I don't know what the MySQL limit is, but basically if your SQL statement is under 4,000 characters for Oracle, it should work. But from actual practical experience, anything less than 7 tables is usually okay. Anything more than that, it starts to get grumpy because then it starts to have to try and figure out what's the fastest way to get through all that data. And the more data you throw at it, the more that it has to know about everything, and the more likely it can be to mess stuff up. Inline views. You can select from a select statement. So if you got a count of all the directions for each recipe, and you got a count of ingredients from all those recipes, you can then join them back to the recipe table and say, this recipe name has this many directions and has this many ingredients. There is more sub-select statements that you can do for filtering. So if you have a query that gives you a result that you want to use that to drive other things, you can say, give me everything from this table where this select statement produces the rows that I want. In this case, it's saying, give me all the recipe details that also have a count of 6 or more directions. There's lots of ways you can write certain SQL. Some databases perform the same thing differently, or the same query differently. Like, the same output can be achieved from multiple queries, and they can produce, they can have very different runtimes, is what I'm trying to say. Sorry. So both of these will do the exact same thing, but they can yield different runtimes. Actual views. So if you have a query that you write over and over and over again, you can create what's called a view in the database. Create a replace view as in the select statement that you want. You can now select from this view as if it was a table. So that one that I did before where I got the counts from these two, and then joined it back to the other table. These are now stored in the view. So now you just select the direction count from the direction count view, select the ingredient count from the ingredient count view, and life is good. Set operations. So there are 4 set operations, and I get to use Venn diagrams, which are always fun for databases. Union is all data from both of these sets. So if you have query 1 that says give me all the recipes from one table, and query 2 give me all the recipes from another table, this will be the all recipes from all tables, or from these 2 tables. There is a way to write this as a join. A union is the same thing as a full outer join, except you don't have access to all the columns anymore. What this set operation is doing is it's gonna run this query first, and it's gonna get all the recipe IDs from this first query. Then it's gonna run this query next to it, and then the result of those is what it compares. So it grabs all the recipe IDs from the first, combines it with all the recipe IDs from the second, and spits it out. You don't have any access to any of the other columns from this table or this table in a set operation. Don't know why you use them. Sometimes it's just shorter, easier to write that than it is to do out a join. A minus operation, kind of the opposite of that. You take the first query, generate a result, take the second query, generate the results. Whichever one does not exist in the second one will be returned. Whatever exists in the first that doesn't exist in the second will be returned. So this stuff. And there's the opposite, intersect. All the values that are in one that exist in the other as well. That also can be written as a join. So if you don't need access to any of the columns, you just want a straight up list. If you have students from 2 schools and you have the list, you can take them to find which students are in both schools. Or you want a master list of both schools, that's when you would use a set operation. All right, we're gonna start skimming because we're close towards the end. Roles and privileges. We didn't set up any users in the database. We're logged in as the root. It's bad practice. But for the sake of the demo, it's okay. Root has godlike privileges inside the database. It can update any table, it can delete from any table, it can truncate from any table. Ideally, you would create users with different roles. If you have a web application that you're sitting on top of this database, you don't want that web application to have update privileges potentially, if you don't want users looking at that. You don't want public people viewing credit card information if you have credit card information in the database. You don't want to store raw credit card information in the database to begin with. You want to hash everything. There are hash functions to store that stuff. So you want to break up roles by how that user is supposed to access, what level of access they have to that data. You want a read-only role for people that are only supposed to be able to query. You want create privileges for developers that are going to go in and change these tables. A role, which I haven't even defined yet, is a set of privileges. So you create a role, and then you say this role has the ability to select from this table, or delete from this table, or create tables in this database. You then assign users to that role so that they have all that. So you create a role for database developer. You create a role for web application. You do a role for people that are doing support for your database and they need to get in and look at customer information, but they don't want access to private stuff. You do that through all roles and privileges. In MySQL, if you go out to the main thing here and hit user accounts, you can create users. I added www, that's not there. The only one that's in there by default is the root user. There is no password for them. To create a user, all you have to do is hit add user, and it asks for their name and any type of restrictions you want them to be able to log in from. This host name, you can tell them that you can create a user that can only log in from certain computers. This % sign means it can log in from anywhere, but if you have all of the people at your company work at a certain domain, you can make sure that only those people with those IP addresses can get in. You can set their password, retype it, and then how it's stored. You can generate passwords for people and create them. So once a person's in there, you can start granting them, or even down here. You want them to have select privileges on certain things. You want them to have the ability to create views or tables. All of that stuff is handled inside user administration. Permissions can be granted globally, so that means every database that's in MySQL you would have privileges on. You can grant privileges at the database level, so only objects that exist inside that database. You can grant privileges down to the object level, so that way they only have access to certain things within a given database. Depending on how you want to handle it, all the options are there. The SQL for it is just grant, and then the type of privilege you want to grant on the object you want to grant to the user. Some other things that we are not going to talk about tonight. Database statistics. In order for this to be able to find the data it wants for you fast, it has to know information about what's in the database. So it usually captures statistics. It gathers min and max of values, how many fields are populated, what the average is, frequency of certain number distributions. And it uses all that to try and figure out what the most efficient way to get the data that you want is. If you're doing a small join where 2 or 3 tables, it's less of an issue. If you're doing 7 or 8 tables, it starts to become an issue. Materialized views. These are like regular views, but they are written out as a table. When we talked about views earlier, when you select from a view, it runs that SQL every time. What a materialized view does is stores the results so that when you select from the view, it goes to the results instead of running the original query over and over again. There are stored procedures for the databases. So if you have things that you want to define and not just do SQL over and over again, you can have a add new user procedure, add new recipe procedure, and you just feed in the parameters that you need to do that function. You don't do the SQL anymore. You embed the SQL inside a procedure. If you have a function you want to write where you have to convert some number to something else, you can create your own function and use that in a select statement. Those are all in stored procedures. Triggers are a special subset of stored procedures. Whenever you make changes to a table, it will fire a trigger if one exists. A lot of times people use this for audit data. So if you have a column in your table that says this row was inserted on this date or last updated on a certain date or updated by a certain user, these triggers will fire and populate that data for you. Different databases have different types of tables. It's not standard. Oracle likes to have a lot. You can nest tables within tables, but it makes it a pain in the butt to try and migrate that out to other systems. So use them at your own behest. And sequences. When we created those primary keys, it was auto increment, but in other databases, there is not an auto increment feature. There is a sequence that you have to create and then assign that value with a trigger to the table as you're adding data to it. So, not in today's discussion. If people want to come back for more stuff, we can talk about it then. And do we have any questions? Is everyone awake? I know databases aren't sexy, but essentially what you have now is a framework to be able to load this up with a bunch of stuff and query it and report out on it on the web, in applications.
In games, this could be used for anything like how strong an RPG character is or how strong a fighter is.
Yep, you can use it for keeping character statistics. You can use it for inventory. I know Asheron's Call, some old MMO RPG, used MySQL as the back end to log all your inventory and your stats and everything. You could actually run board games and stuff off of this. So you would say, you know, my board has 50 slots, so you have 50 columns, and you could say, person is position X, so then when you want to move them, you update them and change the value to this. And pivot that out into a view that actually looks like a game.
Have a table for like birthdays or birth months. So like each month is a key, and then user tables can link to it or character tables can link to it.
Right, so what usually you would have is you'd have a user table and you'd have their birth date in the table. And if you had special logic on certain dates that you wanted to handle, you would usually create that like in another table. So that way you join the user table to your special date logic table. Say, I need to do this. If you want to do leaderboards, player statistics, analytics, how many times has this person logged in? How many times have they gotten a score greater than 5,000? What's their max score? What's the max level they've reached? And that's all just with capturing just when they logged in and what the score was. You can see how frequently they log in.
Just wondering, that root account,
Mm-hmm.
password, is that like the default thing as part of MySQL?
Yeah, that's the default for MySQL.
Is that like
A hazard.
a hazard?
If you leave MySQL running indefinitely, probably. You probably don't want people to get, maybe.
Do you have any
Yeah.
recommendations for people
Yes.
first thing?
So if you're first setting up a database, I probably should have mentioned at the beginning, change your root password. You might even be able to go in a little further. Where it says that you could only log in from certain hosts for root, you could set that up so that you can only log in from the local host. So that way, it doesn't matter if the password's blank. If they're not on your machine, they can't do it. Unless they have some other ways around that to bring up a shell that runs remotely on your computer, and then, so. change your password. Change your root password if you are going to keep playing with MySQL, or just shut down MySQL when you're done with it.
I was wondering about if you have any suggestions around backup and like restoration of like data.
That's going to be a very database specific thing. I can't give you any advice on MySQL. I'm sure there's a lot on message boards. The way that Oracle is set up, I think out of the box, when you install it, it prompts you for backup settings. So when you set it up, it says backup on this increment and tells you where to back it up. And now you know to save that off to somewhere else in case your building burns down. And for MySQL, it does create a set of data files. So if on some regular basis you need to do some kind of backup, you can copy your database files off to somewhere else. I know that there's probably more efficient ways to do it than that.
I have a question. Unique key. Can you explain that again, please?
Okay. So if you have a user table,
Right.
and you,
Like a good example.
yeah, I'm trying to think of a good example of a unique key. All right, so let's say I'm getting data from another organization. They're giving me a bunch of users. They say that their last name and their first name and their phone number identifies a unique person. You can bring that in to a staging table and then feed that into another table with the unique index on there that does that check to make sure that they aren't lying and saying, well, giving you duplicate data. I'm trying to think of a good unique key example.
Because then you talk about foreign key.
Mm-hmm.
But there's a primary key. But I mean the idea of
Stock
unique
prices. Let's say you are writing an application that's logging stock prices. It will insert a stock name, the time, and the price. If you have a primary key that's auto-generated for that field, you still want to be able to say that I only have one price for that stock for that time. So you would put a unique index on the stock name and the price. So that way you know that that value is unique and you're not getting 4 or 5 prices for the same company for the same time.
Okay.
That would be a quick example.
Functions. If they have is there like a built-in converter in a SQL?
To do
Like
what?
for example, like you mentioned, when you do the recipe, like you have to convert like a,
If you wanted to convert like US to metric or stuff like that. There is nothing of that built into the database. You would need to find another table or another source from somewhere else, a physics book, and you would just copy. Your table would be your original units, the units you want to go to, and the conversion factor. So if you had grams to ounces, you'd have grams in one field, ounces in the other, and the number that you needed to multiply your grams to ounces in that third table.
So it's going to be like a custom function,
Mm-hmm.
and you can save it in SQL.
Yes.
And you can use that for.
You can either do it through a join to create that value, or you could do it through a custom function that says convert this to this. As long as you've got the SQL and the underlying data to do it, you can write a function to do it.
Okay. I think that's it. That's all the questions I have.
Another question. So, let's say I'm working on a game with like an online component that
Mm-hmm.
uses it's like use the example of like an asynchronous game, I guess, like a farm or something.
Okay.
Like where users could like affect each other's, you have like their own little plot of land or something like that.
Mm-hmm.
I just had a general question about efficiency related to that, like on the back end,
Mhm.
as far as like if you have data in the database that might be visualized on the client, are there any ways to like make it more efficient in terms of like the amount that the back end is going to hit like polling, and I don't really know what the alternatives are.
Yeah.
Just like polling at different intervals.
Yeah, there's multiple options. It's not really database specific on that end. It's going to be your server technology. So if you're just using Apache by itself and you have a web page that you have to hit refresh every time you want to see an update, it's gonna request that data every time. If you are using something like Node.js, or not even just Node.js, if you're using WebSockets, that will set up a connection between the client and the server, and at that point, the server can initiate contact out to the client and not just the other way around. So every time that there's an update, you can send out the data. In terms of how much gets sent, if you keep track of what was sent the last time the person was in, if there hasn't been any change to their board, you can just not send anything. So depending on what you're trying to do, you would set up the data model to limit how much data was actually going out and how much data actually needed to come in.
It's also a matter of how they're doing the middle parts. Like if they handle the data correctly, do the connections smart and efficient and stuff like that, it's not going to drain the resources of the server as much as if someone who says, okay, I'm going to start a new connection each and every time, do the minimal work on my end, but a lot of work on their end, and that's going to slow things.
So you probably were talking about thread safe. Application being thread safe. So for example, we have like multiple users and you implement like threads. I don't know if you work with like Java or C. So you can give like each user like permission. For example, this user will get like 1 millisecond and then the next one will get. That's what you were talking about?
I'm just thinking of it so much in terms of like relevance on the client itself. But yeah, like I mean, I've worked on games like basically that have like an asynchronous component, but it was the thing where like you'd be looking at the current game state and you'd be able to affect things, but somebody else could come into that environment and maybe like affect things as well. And so it's more like I guess my initial thought was like how you synchronize that. And
What language are you using?
what's that?
What programming language are you using?
In that case, on the client side, C++.
Yeah, in a case like that, you'd have probably some kind of server set up that you're not sending commands to the database, you're sending commands to the server, and then the server is queuing up stuff that says, all right, he planted some corn, put it in the table, and then set the timer so that way in 5 minutes I know to go and say his corn has grown. I know a lot of databases have like an event queue that you can put stuff in the queue and say fire off at this point. And so you list up the actions you want and then have some kind of time in the database that says when this time is reached, then you start sending out new data, but just ignore it until then. So it varies depending on what you're trying to do. What you'll see is there isn't a hard and fast rule for all databases. They're very specific to what you're trying to do. What you might do for a game is very different from what you might do to try and analyze 1 year's worth of Medicaid data. So if people do have databases that they are envisioning, and that's why they're here tonight, feel free to email me or send me text on Facebook, and I'd be more than happy to try and provide any information I can, any feedback. And
I know we're talking a long time back. This one about a game idea, like the clockwork writing thing.
yeah, the poetry.
Yeah, I was always curious, like, just the kind of steps that you went through to figure out what would be the right style of like database backend for that specific case. And so the basic case was like a thing where you could like write a line of text and then send it out to your friends, and different friends can each have their own second line, and then you can see all the different like versions of the text and like tree view, and be able to like refresh it or update it like as close to real time as possible. I think
Yeah.
that was the
Yeah, I don't know if full real time was possible, depending on See, because with a case like that, when you say, I want to be able to view the tree of what I've built, depending on how big that tree gets and how much data can be in each segment is going to really have an impact on how well something like that performs. If you have 1 million stories in there and you know, or if you have 100 stories in there and 1 million people respond to a line, that's a very long thing. To start with that, it would be, what kind of input are you providing? So I have somebody that creates a story. So at that point I have a user, I have a story ID, and I have the starting text. And then what do you want to be able to do with that? You have another user that responds with another line that relates back to that first one. So now you have a parent-child relationship that you're trying to track from row to row, which, depending on which database you're using, is handled differently. But at that point, it's just the same thing over and over again. It's another response to this one now. It's very much like a message board thread. And most of the, I don't want to say most, a lot of forums use MySQL as their backend. Wikipedia, until recently, was using MySQL as the database that drives all of their changes for tracking and displaying stuff. So it can spit out a lot of data. It's just, what kind of limitation do you want to put at that? Do you want a Wikipedia entry that's, 500 pages long, which won't perform as well as something that's 5 pages long?
I'm assuming that somewhere within like the WAMP stack at whatever level, like you could enforce certain rules about like I'm only going to allow this many returns to like a query or.
Yeah, with the database in the select statement, there is a command called limit. So you can select from limit 100 and it would only give you 100 rows back. But you'd want to make sure that you've ordered that data so that way get like one story from here, one down here, and one down here. You want to make sure that you get it in the right order. There's also, for web technologies, HTML5 has a local storage, I forget what it's called, but if you log in and you're watching the same story, you could cache that story locally to their browser. And so that way, every time they go hit refresh, they don't have to go back and get the whole story again. Or if you design the app that it keeps track of, I give you all the new changes to the story, you just keep tabs of when the last time you checked so I can give you all the new stuff. That helps kind of cut back down on some of that as well. So you just have to figure out how frequently you're checking, how much do you want to limit, where you can cache that kind of stuff.
Your table could also have as a column where you specify the parent line's ID number, and then all you have to do is follow that through whatever chain or tree or whatever you imagine.
A lot of times you'll see like a column called parent ID, and that is the link back to the primary key of the parent, and then it has a parent ID that goes back to its parent. The issue with that is that if you're just doing that, you have to either have a database that supports hierarchical queries that says, all right, you have a parent-child column in there, so I need to go get this, and then go this, and then for him, go get that, and for him, go get that. Otherwise, I think MySQL may have just added that, maybe last year, that you could do that. But before you could do that, you would have to select all the parents from this row, and then select the parents again, and select the parents again. So at that point, you say either I can only give you 7 levels of your relationship because I don't want to keep selecting over and over again, or you had to come up with an alternate way to lay out the data. One of the ways, there's a lot of SQL books on how to elegantly solve problems, and trees is one of them. Instead of giving a parent ID, you would give each record a low and high value. So if I'm a parent, I have a low value of 1 and I have a high value of 10. All of my children have a low or high value that falls between that. So instead of having to recursively search the tree over and over again, I can say, I'm the parent, this is my range of values, give me my children. But the problem with that is that you have to make sure that all of your children fall within that range. If you need more children, you now have to extend your high boundary. If your high boundary now impedes on someone else's high boundary, you have to shift them over. So to prevent that, if you have an idea that people are going to respond maybe 100 times to a story, you would pre-allocate like 100 slots for children for this story, and then another 100. And if it exceeds that, then you have some reallocation logic that you have to shift the tree around. But that eliminates all the recursiveness of everything, and you can say, give me all the generations for this family. Any other questions? A plug for Taro. Don't forget to check out Not a Clone on Android and iOS.
Did you talk about, sorry, did you talk about 3NF rule?
I didn't talk about 3NF rule. I talked about data normalization, which third normal format is I believe these tables are in third normal format. First normal format is that no column has multiple values in it. Second normal format is that I get mixed between second and third. So everything that's in a table should be directly related to the key of that table. So if we had one of these earlier tables where I have one table of everything, this ready time has nothing to do with the description of the bread and has nothing to do with the description of the author. So that stuff needs to be moved off into another table. And this needs to be able to tie to a key that uniquely says that this 1 hour and 25 minutes means something in this scenario. Yeah. Well, the third normal format is basically taking it from this table. This table is first normal format. It doesn't violate any rules, but it's not second or third normal format. Going into here and splitting up the tables puts it into second or third normal format. I forget which. I tried reviewing the rules, but it's very circular logic the way when you start looking up that stuff. But
There's a lot of information today, I think.
yep, no problem.
So, if it's all right, we'll leave any other questions or like an individual discussion. There's two things that we do at the end of these lesson nights. First is we pass a hat, and so these are, pay what you can lessons, but the majority of the money goes directly to the speaker, and then a small amount for just overhead of the meetings and the game space. So yeah, if you have money that you can contribute, that will help us keep these going. That would be appreciated. The other thing we do is we tally up the votes.